Hello, good afternoon. My name is Laurent Haug. I'm going to be your host for the second anticipatory briefing of the 2025 GESDA event. So we are going to talk about the evolution of extended reality. We hear a lot about augmented reality. We hear a lot about virtual reality, but there's also extended or mixed reality, which is a huge field. Extended reality is transforming how we design, build, and interact with the world by integrating physical and digital environments. Advances in immersive interfaces and intelligent systems are redefining creativity, collaboration, and problem solving. In this session, we will explore how XR will reshape innovation, productivity, and education over the next 5, 10, and 25 years. Our speaker today is a Donald W. Feddersen professor at the School of Mechanical Engineering at Purdue University. He's going to speak for 15 minutes, and then we will take your questions for another 15 minutes. Please help me welcome Karthik Ramani.
Yeah, thank you. So I'm Karthik Ramani. I'm a professor at Purdue. And my lab researches in what we call human-centered spatial computing. To simplify, we look at developing and testing new technologies where we use our eyes, our hands, and our voice to interact spatially with things around us. So to start with, in the 60s, Doug Engelbart invented the mouse. And together with the mouse, he envisioned an entire ecosystem, and out of which came ARPANET, the internet, and many other technologies. He also demonstrated collaboration with the mouse. Today, as we know computing, we work on a computer, we sit in front of it, use a keyboard and a mouse. But he also demonstrated, for the first time, something which has now transformed into what we call augmented reality, extended reality, and so on. Putting the computer on our heads and what we see into our eyes and projecting virtual objects in the physical world as if they exist in the physical world. So AR is not new. Today, we have a lot of these large companies and others trying to develop new types of headsets with advanced capabilities, and also regular-looking glasses with much lower capabilities. So I'm just going to demonstrate very quickly one of the pieces of technologies in this area that we developed maybe 5, 6 years ago. It's just an example. What you see here is a human interacting with the hands while, of course, wearing a headset, turning this cookie monster into something virtual, a virtual replica, right? And then manipulating that in the physical world. So what you see has happened is not only has a virtual replica of it been created, but also one can render new behaviors to this new cookie monster. For instance, if you were wearing all these augmented reality headsets, I could ask one of them to sit beside you. Not that you want to have that next to you. So these types of technologies, Mark Weiser has said in 1991 that these technologies will end up weaving into the fabric of everyday life, and we cannot distinguish the technology as being something separate. For example, including AI, put together with extended reality, I will be talking about how that can change how we think, how we play, how we design, how we interact, how we communicate, including in meetings such as what we are having now. A little bit of a context here. So XR is not just immersive. It's not just what we touch and what we do in the physical world. It's also a lot about how we are immersed, how it's changing how we think, our intent, and it's going to respond to us. So it's not a single one-way communication with the augmented reality environments. The environment becomes our playground. So it's going to shape how a lot of things we do in the physical world, how we teach, how we collaborate, including how we work with machines and we work with humanoids. And very fabric of a lot of what we work and play can be enhanced by extended reality, together with the major advances that AI is having on such technologies. How we sense, how we reason, how we play, how we act, and the so-called co-intelligence, it becomes augmented with us. The AI is with us. We are carrying it with us. And it changes a lot of things. So think about AI together with XR, not XR as a separate technology, but all the advances that are happening today is in fact going to power extended reality into starting to do new things, and inanimate things become alive. You can use them as controllers. You can use tables as desktops. So sort of projecting ahead, this was a demonstration that was done very recently, just 3 weeks ago. You might think, oh, I've seen a lot of these extended reality technologies and features and so on and so forth. It's so hard to create them today. You need coders. You need assets in 3 dimensions. It's a lot to think about and do. However, things are changing rapidly here with the availability of LLM together with AR technologies. What we were able to show, for example, here, is an agentic version of it. What it means is you have an agent for everything. Agent for asset creation, agent for detecting your interaction, your perception, where you're seeing, what you're touching, and what you're doing. All the interactions, we call these embodied interactions, can be seen now. And the LLM agent creates the program. So all you do is you tell the LLM agent, can you help me make coffee with all the elements that you see in our surroundings? So it perceives the context, it understands where you are, it knows what you want to do, and given the LLM capabilities, we were able to decompose this and create a whole bunch of instructions to configure the back end and the front end to create your application. So we took about 60 or 70 past publications published in the last 3 years. And in the past, some of these applications, including our own, took us months to create, maybe a year. We were able to do it in a matter of days and even a few hours and 10 minutes. It surprised us, but this is possible now. So it's not just making a coffee, but also it could be, for example, show me a simulation. Show me, let's interact with the molecules. You change docking problems and everything into an interaction problem and put together quantum computing on the back. Forget the technology. We have to think about what it can do to us. So as I was suggesting, as simple as a coffee making, I can say, hey, put the interface here. You know, I want to grind to a much finer coffee, right? So it's not just the coffee and coffee making. It was one of our examples, but a whole bunch of other things that we were able to demonstrate in terms of what you can do just by talking and showing to create applications. So design essentially becomes a conversation. Creating these applications becomes a conversation, and showing and telling, just like we interact in the physical world. So we call this agent AR. So it's kind of the idea of agents and tool-augmented agents. These agents become our tools. So the tools become our capabilities, and they are configured automatically to do a lot of things. So this is going to have profound impact. In fact, a lot of companies have moved and shifted a lot of their investments to AI, but XR has been ignored, but it's in fact getting better and better in terms of what we can do. For example, in assembly, I'll show you in a little bit augmented reality training for playing table tennis, a high-performance sport, and this is going to push our development of technology. I'll show you how this technology can deconstruct human skill, and you can transfer it to humanoids, for example. Or you can interact with robotics, and maybe the robot will tell you how to program it, right? Or learning mathematics and visualizing these on the go, spatially. So a lot of different applications, from robotic surgery to sports to education to assembly. All of these are going to be completely transformed, both with AI and XR technologies. So here are some examples. For example, here, the bulb is virtual, and we have a static gesture, and it responds to us. And here we replicated the mug. The mug actually knows how you hold it, so it responds to you in terms of how you hold it and how you move it and so on. But it can also be dynamic interactions. For example, this Coke can just vanishes in front of your hands. And also, you can give behaviors to these objects, right? So it's not just a spring, but think of more complex situations where you can do a lot of these things more easily. So beyond this time, I want to show you a little bit of how it can help humans work, how it can detect the human status. It's not one way. It understands what you're doing with your hands, and it adapts to you. If you have more difficulty, it comes and helps you more. It gives you instructions. It judges your state, and it can come and correct you. This will have enormous implications on how we think and do things spatially with our hands and body. Instead of being slapped in front of a two-dimensional computer, sitting in front of a mouse, you have spatial technology with you everywhere. So a little bit of what is happening in the back end there, right? This is for tutoring, for somebody to use a laser cutter, right? So the low-level recognition happens, it records, understands from an expert, and then it adapts to the humans as you're doing these various tasks. This will have enormous application in a lot of our labs and so on and so forth. And it can extend the TA, for example, the coaches and the teachers. You can do 20 people at one time instead of 2, right? Just imagine that. So this is not going to just happen. There's going to be a lot of plumbing needed. Technology is going to push the needs for edge AI and things that we haven't thought about. And it's going to push us in terms of what we can do in our research. Oftentimes, people think of research as being linear, as we do something and it goes into the real world and becomes real. But more than that, the real world can also affect a lot of what we do. And if we give access to these types of technologies to many people to develop on, it's going to accelerate. So what we also see is that it's not just skilling. We can skill humans, but we can scale the skills, right? We can transfer that. We can train robots. And with the convergence of many technologies like wearables, AR, AI, and high-performance computing, we are going to see a big transformation in terms of a lot of different things. So moving forward, here is an example. I myself play table tennis competitively and also coach our team, which is a top 10 team. So I use this as a use case. So we have actually an agentic coach now that can learn from an expert. The AI learns from an expert. It can track the ball in real time fairly well. And table tennis is a very cerebral sport, right? Decision-making, the skills, and very split-second decisions have to be made, 20 to 30 milliseconds, right? So we are trying to work on these as an exemplar. And what I'm going to show you is pretty interesting. We worked and were perhaps among the first two to show leg movement emerging in a humanoid robot, which has learned from a human. Currently, the humanoid robot simply hits the ball over the net and aims at a particular target location. And it's been only 3 weeks since we got this done. So to power this technology even more, you can train thousands of humanoids in simulation under different conditions and then transfer them to the real world. So using athletics as a high-performance push to our technology pushes the science. And this is collaboration with one of my colleagues, Yan Gu, who works with humanoid robotics. And also now applications to other areas, such as drilling. You actually see a person doing drilling, training in drilling, high-performance riveting, surgery, and all of these. Moving it from a high-performance area to low performance becomes much easier. And you can do thousands of real trials, seemingly real trials, and have vibrotactile feedback in your hands as well. So what seems real, feels real, is real. So your training becomes extremely real at much lower cost and scale. So we are kind of entering this age where I believe AI is going to power XR even more. It's going to co-evolve with us in the physical world. It's going to have impact on how we do a lot of things. It's going to learn with us, along with us, and potentially even surpass us. So I think that in the next 10 years, we'll probably be able to get the humanoid to do high-performance table tennis. So in this extended world, extended reality world, and the co-evolution of humans with XR and AI is going to really transform a lot of fundamental things that we think are innately human in terms of human skills and co-evolve with the technology. So this XR that we are looking at in terms of not just a spatial medium, but also something as becoming a part of ourselves, right? So in that sense, it becomes our interface. So we are the interface. There's no need for interfaces at all. So I kind of call this zero UI. So the humans, we becoming the interface and we interacting with the technology. So the next revolution will not be on your screen. It's going to happen in the space between your body, your mind, and in the physical world. To summarize, what I've said so far is that the tools will become our partners. We will co-evolve with these tools. And the apps become the environment. And eventually, we become the co-creators of this future technology. Thank you very much.
Thank you. Thank you very much, Karthik. So right on time, very Swiss of you. Thank you very much. We have time for questions. Please raise your hand. We're going to bring you a microphone. We have a first question. Before that, let me jump in quickly while we bring you the microphone. So, I mean, in a way, we've been hearing about this in the public discourse since Google Glass, which is now more than 10 years old. Since we had HoloLens, which we haven't heard about for the past 3-4 years. I don't know if there's an update, but it's becoming an old device. Apple has launched an extended reality, the Vision, and has noticeably struggled with it, commercially speaking. It's quite spectacular to try, but it's still very expensive. Meta has shown some prototypes with glasses that actually beam light straight into your eye, saying immediately, this will never be a public device. It's too hard to launch and produce. So when is this going to happen? Because we've heard about it for a long time, and it seems to never materialize concretely.
It's a great question. Very simple one-line answer. 3D with humans is not 2D plus 1D. So when you're interacting in real media, there are a lot of challenges and a lot of possibilities, number one. But also this technology and the we shouldn't look at it as a headset that we are wearing. We should look at it more as an immersive media. And a lot of things have to happen in an ecosystem to elevate the technology to the level that it'll be more ubiquitous. And they have to figure out a way to make money, right? So given all that, right, there's a lot of challenges in the hardware, in the connectivity, in the bandwidth, and in the applications that you want to create. For example, 2 years ago, I couldn't have made this agent AR and claim that we can do something which takes 3 months in a matter of a day, right? This has to happen at scale. So unless we allow users to participate, sort of think about the smartphone ecosystem. Everything evolved, right? The app base, the user base, the phone. So we need that kind of a setup to start. And these companies doing experiments and spending money is pretty good.
It's a good metaphor because mobile phones started as like full things you had to carry like 30 kilos around, and then it became a device we all have. But you mentioned the difficulty of all the technological block, you mentioned the price, but also there is a social factor, right? It's still weird, like you see people in the street wearing such devices. You know, famously there would be, when Google Glass led to the birth of the glass holes, right? People filming you all the time, and like there was quite negative return. So my question is like, what's the final form factor? Do you think it's going to be glasses, or is this something that we cannot imagine today, and we can see the world in a mixed way without having to, in a way, reject the people who are immediately with us?
Yeah, that's a good question. Today I see a lot of people walking with smartphone, and their mind is elsewhere, except that they're not wearing glasses. So I think it'll happen bottom up with some of the new glasses like the Ray-Ban and others that are coming up, and people will get used to it. But I do agree that there's going to be other issues surrounding the social side of it, which I think are going to be important. But yeah, we'll see what happens.
It's true that already a smartphone on speaker, people making their calls is absolutely terrible. Sir, you had a question, please. Introduce yourself and ask your question.
Hello, my name is Minyoung Kim. I'm a mathematician. How long do you think it will be before you can tell an AI, hey, improve this extended reality system?
Improve it?
Yeah, tell that to an AI.
You know, because AI, we use AI now, it's multimodal, so we can create text, we can now create images, we can create video. Can we expect one day that we can ask an AI to actually build 3D models, which you just described as an extremely complex problem?
Actually, you have described my next PhD's problem. So that's a really good question. I think we have tools to help do that. Of course, it needs feedback on what is good and bad, but perhaps with multiple people using similar features, there's some kind of a crowdsourcing. It'll learn what is good and bad and adjust to your interests. But yeah, theoretically, I think it's possible in the next 5 years. Yeah. The basic AI improving your experience, right? Let's say you're only 30% happy, it'll get you to 70% happy, perhaps.
Yeah, AI is always about data, so we need more data to be able to reproduce. Can you please stand up, introduce yourself briefly, and ask your question? Thank you.
Yes, hello. My name is Laurent. I'm a neuroscientist working with animal models of how the brain gets rewired in different situations. And one of the things we know from neuroscience is that when, for example, you lose an arm, or even if you already stick your fingers together for a longer time, at the cortical level, you get a rewiring that takes place.
Correct.
So my question is, if you're going to expose people long time to virtual reality, what's going to be the consequences long term for the brain? And is that not something that you should take into account before exposing people?
Yeah, that's a really good question. We call it proprioception. I'm sure you know that,
sure.
Coming from that area. So I'm very closely working with some neuroscientists in terms of understanding how muscle memory works, for instance, right? For example, like in table tennis, we are coaching people. So can we sense what's going on in your muscles using EMG and EIT and help you change your behavior and your movement? Because you don't have time for decision making there. Perhaps the decisions are made in your we don't know where, right? Those split-second decisions. But that said, right, I think your point of using the body and what your body is doing, for example, if you hold your arm all the way like this, it's called the gorilla arm syndrome. But people are working on micro gestures and other things which you can handle and do just by rubbing your fingers and so on and so forth. Yeah, so there's a lot of very, very good questions in this so-called embodied AI, which is yet to reach some kind of understanding and definition, but certainly the neurophysiology and a lot of other things that happen in neuroscience has to be brought into consideration in research in this whole embodied AI.
If you have a question, please raise your hand. It reminds me, in Switzerland, a decade ago, we had a startup called MindMaze, and they wanted to use virtual reality, or at least immersive devices for re-education of patients who had lost a limb, for example, or who had cerebral accidents. So is that something that could be also used?
Yeah, absolutely
an
right.
application for this technology?
Yeah, absolutely right. So, so my colleague, Hogan, who's right across, I'm spending my sabbatical at MIT, he researches rehabilitation technologies and several others, people in Colombia and so on, working closely with hospitals are trying to use VR and AR to help rehabilitate people from various conditions.
And you think it's a promising?
It's very promising.
I'd like to ask you more about the current examples. So if you have questions, please raise your hand, but I'll get to ask mine in between. So it really started with virtual reality, right? This whole field, this idea of projecting stuff and living in 3D worlds. Then for a while we talked about augmented reality. Now mixed reality or extended reality seems to be the thing. Where are we going? What's the mix that we're going to end up with? Because Facebook, when it was called Facebook, actually renamed itself because the CEO really believes in something that is called the metaverse, which has not really taken off. So where is VR going? Where is augmented reality going? It seems a bit of a gadget. Do you think in the future XR is 80% of the market, or will these things coexist? I'm lost on predicting which one will work.
Yeah. So it's good to think of it as a continuum, right? If you had a slider bar, can I go from like more totally VR to somewhat augmentation to more being in the current world, right? So it's a continuum. That said, I think last year we had a demonstration by Facebook, and it was pretty shocking. There's something which we call an uncanny valley. And they showed that in VR, you wearing the headset, we have crossed that. What it means is that if I haven't seen you physically, I've seen you in VR. When I see you next time in the real world, I wouldn't know. It would seem that I've seen you before in the physical world. So from a technology perspective, that realism has been crossed, right? So from our point of view, the way I like to think about XR is not as a device that you're wearing and not that bulky thing, which doesn't suit many conditions that we want to be in, but as something that augments you in doing a lot of things and also helps you in more spatial interaction and so on. So a lot of different people have been trying to play with different types of applications. And these companies, for example, are looking at large-scale ubiquitous applications of these type of technologies, right? And I would say they're still struggling to get their footing strongly in this area.
And finding a business model, right?
Yes.
But as you say, it's a continuum. So augmented reality is I take my device, I scan something, and something pops up on the screen. Extended is I wear a device that shows me the world, on top of which I add digital objects that don't exist, or HoloLens. And then VR is I'm fully immersed and I'm playing Beat Saber on Oculus Quest, for those who know. And so what's also interesting, it seems some devices are merging, right? On the vision, you can switch from I see the world and I add objects into it to I'm fully immersed. So maybe the frontier is going to disappear, or it's just going to be at the flip of a switch that you go from I have a physical object in I have a digital object in a physical world to I'm fully in the digital world, right?
Yeah, all of those are possible.
All those are possible. Yeah, we'll see. And finding a business model is apparently a big struggle. One of the reasons that maybe these examples are the technology is struggling to take a foothold is like, what are the concrete returns on investment? So, for example, you showed this training where I have to repair a device and I get guided by augmented reality or mixed reality. Can you give us? Have you guys measured the concrete impact in terms of gain of time on a task or in gains of dollar? Like how much, what do I get from investing in
Yeah, it all
reality?
depends on the application context. For example, if the cost of an error is $10,000 or $20,000, right? Or a human life, like in surgery, or in very high precision manufacturing operations, like in aerospace and so on, there the payoffs are there, and we are seeing traction there. So you often need some sector to pull up the technology and challenge it, right? And it pushes it, and then you are able to get past into a viable business model, right? So it's a complex interplay between technology and users and the benefits from it, right? So for example, if you take the phone, was there a clear use case
No.
of the phone?
No. But it was an open platform and people invented the use case.
Yeah, and the BlackBerry went away, right?
Yeah.
We don't even talk about the BlackBerry. So I personally think that we are at somewhat an early stage, and these companies have become over anxious to develop new tech.
Thank you.
Good evening, Dr. Karthik. Excellent presentation. I'm Naga Chaitanya from TriQuanta Labs India. In the era of quantum, how do you see the application of XR in teaching quantum education and dissemination of extremely complex technologies like neutral atom or other technologies across the world?
Yeah, that's a good question. So in terms of understanding anything new, I think AI with XR can play a big role, right? Because you're actually experiencing things and you're immersed in it. For example, some of the experiments we have done, we introduced AI agents into a real classroom. And the students didn't know that the AI was there. So it was playing a role of like engaging the students more, note-taking, and helping in visualization and so on and so forth. So I think there can be a lot of collaborative settings where the AI can adjust and the XR can adjust to the user and what they want because they can explore in many different ways, right? So think about YouTube. How many YouTube videos are being uploaded every second? So can you think of ARTube in the same manner, right? So if there's millions and millions of AR video tutorials being uploaded every second, you're going to have a lot of people. How many people learn from YouTube today?
Yeah, exactly. YouTube has become the new Wikipedia, actually, where you go there for knowledge.
Yes.
Sir, we have a red screen flashing about the time, so we get into very quick question territory because we have one other.
So
Please.
I use YouTube videos to help me with bicycle repair, which is great because I can repair my bicycle. But I go back to my bicycle and I have to watch the video again to do it the second time.
Correct.
Right? So I'm wondering how we can incorporate, how much you're attempting to incorporate pedagogical theories, theories about learning and plasticity to augment that. And sorry, my name is Joshua Gordon. I'm Columbia University neuroscientist and psychiatrist.
Yeah, so we have done the bike example. So we worked with welding mechanics, textbook writers in welding, and so on. So it's also about causality, right? It's not like a one-way street. The XR and the AI tells you why you're doing what you're doing the way you're doing, right? So it becomes a medium where you can explore and go in different directions. So yeah, to your bike example, the amount of time to create that app, it's much faster than creating instructions in PDF and putting it up there, because all you do is a demonstration of what you want as an app, and it comes out of it. So anybody can author now. Anybody becomes a creator. So I think the avenues for learning, not just the bike, how the bike is designed, how it's made, how it's built, and all the other, stress visualization in a bike, how the gear mechanism works, and then exploring that, the dynamics, the statics, and so on, right? Materials, strength. You can learn so much from a bike.
We have one last section. Sorry, it's going to be the last one. Please make it quick.
I'm Maxim Bans, and I'm a high school student in Zurich. I'm here on behalf of the Villars Institute. I have a question. You can comment briefly on it. In a world where we are slowly losing creativity and the use of our own ingenuity with the rise of AI, how can we protect the creativity and ingenuity of people, especially with the development of XR and other technologies?
Yeah, that's a really good question. I think I can give you various answers to this, but bimodally speaking, right?
I think the short answer.
Yeah, short answer is human creativity is changing, can change because of technology, right? If you depend too much on technology, I would suggest put your ideas first, play around with the ideas before you bring tech in, right? So if you right away go, it becomes a crutch, and it starts doing stuff for you, and then you get fixated on ideas. So to explore is more important as a human before you start using technology.
And if you're an author and an AI has stolen your work, sue them. You might make 1.5 billion like it happened last week. Big round of applause for our speaker, Karthik Ramani. Thank you.
Thank you.